All right. So I just kind of gave a little bit of a primer to that. So my name is Bryan Soltis. I'm a Kentico technical evangelist. Kentico is a .NET-based CMS. I'm not really talking about it today. I'll show you a little bit aspect of it, but it's only because that's where my data is. And my job at Kentico is to help developers use it. If you come across Kentico and you have questions, reach out to me and I'll be glad to help you. If you come across questions with Azure, reach out to me and I'll help you with that too. I love working with Azure. I've worked with it since it existed because I was part of a program with Microsoft, like the SQL Azure Buddy program, so I helped them shape that. I used Azure Web Apps before it was Web Apps. It was this thing called Atlas or something. It has a strange name, but I used it for a long time. I used all different parts of Azure. I'm a web developer, so most things I do with web. I do have some infrastructure knowledge, but I'm mainly a developer. And I came across Azure Search about a year and a half ago, and I've given this same talk several times, but they keep putting out new features, so I just keep revamping it. So before I get started, has anyone used Azure Search? Okay, well, one person, Brandon. Hopefully I will show you something you haven't seen. I was telling them that because I've given this talk so many times, and I really like it, and it's really cool, which I'll show you. The program manager for Azure reached out to me, and he's like, hey, thanks for talking, and is there anything we can help you with? And oh, here's new features. And so he tells me new features that aren't even released yet. He's like, see what people think about this and see if it's cool. I was like, okay. So I give him that feedback. So getting into that, I'll give you just a little brief overview of Azure. We'll talk about how the indexes work, searching, which is a pretty big part of Azure Search. We'll call it the advanced features. And then I'll show you how Microsoft provided some tools that you can analyze your search data, which is pretty cool. And I'll tell you how much it costs. And I'll give you a bunch of links where you can learn more stuff. So this is your first chance to win a t-shirt. This is the easier question. Does anybody know what that is? First one to tell me what that is? There you go. You want the large or do you want the extra large? Okay, that means whoever gets the other one's getting the extra large. So this is t-shirts that they sent me. So you get an Azure t-shirt. So why Azure Search? So search is obviously very complex. It's different to different industries. It constantly takes retooling. You have to shape it. People are going to search your information in different ways, and they expect to get their results in different ways. It's very specific on how you search for something. If you go to look for a book, you might go by the title, the ISBN, some keywords. If you go for shoes, you're probably going to go by color, type, style, brand, whatever it is. So the way that search differs is just astronomically complex because of the way information is looked for and the way people expect to receive it. It's difficult to know when you're going to get a big load of a lot of people searching and when you're not. And the biggest thing, and my favorite part of it, is if you don't know if your search is good, if it's not good, you're going to find out really fast because people will love to tell you how they can't find anything on your site. So because search is so complex, I think that's really why Microsoft recognized that this really was a growing need, and the fact that Amazon had Elasticsearch, which is 2 doors down, I believe. He's talking about Elasticsearch. But basically it's a cloud-based SaaS that you consume within your application. And everything is done through an HTTPS REST service. It was actually released in 2014. I was telling him, like I said, I've worked with Azure since like 2009. And it wasn't until mid-2015 that I have even heard of search, because I was bored and playing around, clicking around in Azure. I'm like, holy shit, this looks really cool. But it actually was released in 2014. Everything's completely hosted in the cloud. And the idea is they basically removed all the administration for you. You give them the data, they do an index of it, you make calls against their service to get your results back. They're managing obviously the hosting of the content repository, they're managing all the load that comes in, all the calculations, any kind of scoring that you want to do, all the fun stuff that you would have to build out your infrastructure to do, you're offloading all onto Azure. They have multiple plans. There's what is called the free plan, which you're going to see today because it's free. Basic, and then now there's standard. There used to be standard. Now then there was standard S1 and S2, and now there's S2, S2, and S1, S2, and S3. You'll see the pricing on that later. And they basically have just different capabilities, what kind of SLA that Microsoft has in play, how far can you scale up, and things like that. I'll break those down later on in the presentation. It's available now in 12 data centers. Basically every major region you can do Azure Search. I know East US and West US. Actually, I think East, West, and Central, I think all have the capability to do Azure Search, but not both. There's two East USs. There's East US and there's East US 2. Only one of them actually is capable of doing Azure Search. So there are multiple tiers that you can scale up to. If you need a lot of horsepower, you can scale up and scale back down as you need it. And what's really cool is they have a lot of analytics built into it that I'll kind of demonstrate to you, because just like everything else, Microsoft is kind of watching everything that comes through their servers, and they're able to retain that information and then do like some calculations and aggregation on top of that data, as well as machine learning and prediction and all kinds of stuff like that if you really want to get into it. So the first thing that you have to have is you have to have data to search. That data, much like basically what's behind Azure Search is Lucene.net, just like every other search everywhere, because it's like the most capable one. So that's basically what Microsoft is doing. They're using Lucene.net libraries behind the scenes to, you give them the data, they create the indexes on it, and then you perform the searches against those indexes. As of this moment in time, that data has to be hosted in Azure. What that means is your data is already in Azure, which means it could be in an Azure database, it could be in Azure tables, and something, I think the NoSQL database was DocumentDB in Azure. Or you have to push your data into Azure. And then Azure Search will create indexes off of that. So you have two methods. There's push and then there's pull. And then each index can have up to 1,000 fields. So every record of data that you put up there can have up to 1,000 attributes, I guess, so to speak, that you can put on that. And each of those fields, you tell Azure how to deal with that particular thing. So this is actually, I'm going to trip on that. This is I'll show you the code in a second, but this is actual code using the SDK. So if you notice, there's SDK and there's a REST API. So again, everything that happens in Azure Search is a REST API. Everything's going through the REST API. They put out an SDK that, lo and behold, calls the REST API. It's a lot easier to code against the SDK than it is just doing straight up REST calls. But behind the scenes, everything is going through there. And you basically tell Azure, here's my data, this is what each field looks like, and this is what I want to do with it. And I will show you lots of code. I'm just going to get through these. I realize I need to kind of move some stuff around before I get into the actual code. As of right now, you can only search against a single index at a time. I know this is something that they're looking into, being able to span multiple indexes. It does full text queries, so it uses prefix matching. I'm not a super search guru to know every little character that does everything. I know how Azure Search works, but I don't know everything about the Lucene.net library. We actually use that inside of Kentico, and I remember looking at the documentation. I imagine it's about that thick for Lucene.net. And I'm like, I know how to make an index, and I know how to do a regular search against it, but there's all kinds of wildcards and different things that you can do with the Lucene library. So the data behind the scenes is using simple query syntax, and you use a lot of OData data types for all your different fields. So if you have Booleans, you have dates, they're all OData data types. And you can do search asterisk, you can do wildcards, all kinds of different things. You can also do things that are called scoring profiles. So you basically can tell Azure how to rank the results, and that can be dynamic. So if you want to, let's say you have shoes and it's important for you to know the brand and it's important for you to know the color, you can use different scoring profiles for each of those searches, and it will rank the colors will be higher. The brands that he's looking for, it'll rank those higher, or the most relevant ones. You will rank obviously the other category. And apparently I felt compelled to tell you that it has an SDK and a REST API again. So a couple other really interesting highlight or advanced features it has the ability to highlight, meaning you can highlight the results as they come back, which is really cool because it all happens on Azure side, so you just get the data back, and I'll break that down. You can do facets. So if you say you search for shirts, it will break down each brand. You can have each brand, and it'll tell you how many results are in each facet. So you can have multiple facets. You just tell the field that you want to work with if it's facetable or not. You can filter. Oddly enough, that's what most people do with searching. So if you want to say, okay, here's all here's all the movies I was looking for, show me only the comedies, and you can filter on a facet so that it only shows you the comedies. You can do things called suggestions. So basically, as you type, it will try to figure out what it is you're looking for, and you can do like a type ahead thing if you program it appropriately. It's a different API call to get the suggestion, but you tell it which field you want to get suggestions from. So as they type, you can get those suggestions back and display them to the user. You have lots of different things like different analyzers of how the data is actually looked at and how Azure Search is supposed to search against it and understand it. And new thing, I just found out, like, they have things called synonym maps. So you can tell it on this particular field, if someone searches for this, also include these things. So different synonyms that they may not type, but you know that they're related to it. And it also supports cores, which will allow you to lock down what has access to your service. So you can say only this particular IP has access. So now enough talking, and I'll show you some code. So let's see. So the first thing I'll show you is you have to have an Azure Search service. That's generally pretty important. And it's not really important what's inside of here because I don't really have anything set up at the moment anyway. But this is my search service that gives me all my information, tells me how many documents. So before I get into that, when you put one row of data into an index, that is a document. Every single row is its own document. That document can have up to 1,000 fields, but it's a document. Your plan limits on how many documents you can have and how many indexes you create. So if the free plan allows for three indexes and allows for 10,000 documents. So if you make 3 indexes, you can only have 10,000 documents across all 3 indexes. It's not really a big deal if you go with the standard plans because you can have, like, I don't know, 5 million or something. But it comes into play when you're demoing and you can only do 3 indexes on the free plan. So inside of here, this is where you're going to see information start to come up as I create these indexes. So just to give you some context of what it is I'm working with. So I have data that I'm going to be using that I want to search against. So this is inside of Kentico, and this is in our MVC implementation. I have a bunch of Simpsons quotes. So you can see them on the left. It doesn't really matter. You'll see them all in a minute. But you can see for each quote, I have like an author, I have a text, I have a date that I'm not really using because I haven't put that into it, and I have a latitude and longitude. So it's where the quote was done because I needed that to show something else. So I have all this data sitting in our Kentico. This is the administration UI. I'm going to pull that data using some Kentico APIs to get it into my MVC application, and then I'm going to use the Azure SDK to create an index within Azure and then populate it with that data and then search against the data. And I have 2 different projects that I'm going to show, and it's because when I first did this presentation, there wasn't an SDK. So I have a lot of code that is in just a standard web forms app, and it's a lot of just straight REST API calls. I'm not really going to use it for most of the things except for near the end because the SDK lags behind the REST service. So the REST service has a lot of capabilities, but the SDK doesn't necessarily doesn't know about everything the REST service can do. So most things are in the SDK, but there's a couple things that are only in the REST service right now. So I'll jump back to it, but that's why I'm going to go back and forth a little bit. But mainly I'm going to be inside of my MVC app, and I'm going to do everything through the SDK. So this is my awesome demo page that has a number of things. So I have create index, load index, delete index, and then I have some search capabilities that I'll demonstrate. So the first thing I want to show you is how you create an index. So using the SDK makes it a lot easier, but this is where I'm basically creating the new index name, and then I define each one of the fields that are going to be in my index. And for each field, I'm telling it, is it searchable, is it filterable, is it the key, is it not? And that really is just it doesn't matter what I put there, it's how Azure Search is going to deal with that data and execute the commands against it. If you want to get data back, you have to make it retrievable. Sometimes you have data, like I have the document ID, well, like the document ID, that's our own internal identifier that I'm using inside of Kentico, but I want to move that, but I don't necessarily care to get that back in my search results. So I do get it back, but I don't search against it. Sorry. confuse my words. I don't really care about searching against it, but I do need to get that back in my results. So it's really important how you set up each field because it depends on how you're going to interact with it. The next part of this, and there's several different things in creating this index, because this is basically defining the structures of how all the index is going to work. So there's a lot of different pieces. One is all the fields. Two is the suggesters. I know I want to do suggestions on the author. So basically, as someone starts typing, I wanted to figure out, did you mean this particular author? Because I know I have 10 or so different authors. I have like 100 quotes with all kinds of words in it, so it didn't really make sense to do a suggestion on the quotes, but the author, it did make sense because they're the same author. Mo says several things. Bart says several things. So I did want to have an autocomplete there. This section is how I set up my scoring profiles, which I'm going to talk about them. Sorry, I did jump down. To tell you about it is a little strange. When you see it, you're like, oh, that makes a lot of sense. But the code, it's not really that important. But I'm basically telling it, weight these particular fields. So make a scoring profile for author, so that if you say, show me the authors that match, it will rank those higher. Where it thinks that the author, because it's going to take anything in the author field, and it'll think that that's a more relevant search. If quotes are more relevant to what the value you're looking for, there's another scoring profile called quote text. It's going to rank those higher. And then this one is a complex one called quote location that I'll show you, where you can search based on a particular location, a latitude and longitude, and it will calculate which one is closest to you. That's why I have the quote latitude and longitude, so I could demonstrate that. But all of this code basically processes and creates an index inside of Azure. So it's not very exciting from this standpoint, because it's going to say index created eventually. All right, let me reload that. OK, there it is, index created. It went away as soon as I did it. But if I jump back over here, if I refresh this, sometimes the portal will refresh, sometimes it doesn't. I don't really know why. It just, even inside, some like screens will refresh. So if you notice, here's my quotes, which is a little fuzzy, but it's OK. But this is what I wanted to show you. This is the different fields I created with the settings that I have for each one. And then these are the scoring profiles that I created. Again, when you see them in practice, it'll make a little bit more sense. But this is where you're doing, I'm not setting any CORS options because I don't really care. Everyone can hit my service if they really want to. So the next piece that I need to do is I need to populate this index with data. Now, in this case, my data is local. So I need to get the data in my local machine and push it up to Azure using the REST API. If I wanted to, I could have that data already in Azure and create the index based off of that. But in this case, I'm doing it local and then pushing it up. So in here, I have another button called load index of all things. So inside of here, they're doing a couple things. So this code right here is using our API to get that data from my Kentico repository into essentially like a data set. And then I'm going through, for each one, I'm creating a new object called quote. And I'm populating a list of quotes. And then down here, I'm doing index.batch new, and I'm saying upload all of those quotes into Azure. Now, that quote object, these properties correlate directly to the index fields that I created. So when I push them up in there, it's going to map all those fields, and off they go, and all that data will just jump up into Azure. And in this case, I think there's 98 of them or so. So I'm going to say this. And you're going to see index loaded. So just like that, the data's got pushed up. If I come over here, probably will have to refresh. You should see this change to like 98. We'll see. Sometimes it takes it about 20, 30 seconds. But I know the data is there because I can already search against it. Yeah, I'll come back to that. I already know it is there, though. So from here, now we're actually ready to search this data. So there's a lot of things that you can do with searching, and I'm going to try to make it iterative. So I'm going to start with a very basic search, and then I'll start adding the new features. So for the very basic search that I do, let me collapse this down. If you have any questions along the way, please fire away too. I like to talk, so it's OK. All right, so the first thing you're going to see is my suggestion, because as soon as I start to type in there, I have some JavaScript on that page so that as soon as I start to type in this box, when I get to 3 characters, it will automatically make a REST API call to Azure Search with the suggest method to try to get back things it thinks are matching what I'm searching for. And that code is going to happen right here. So it's going to create a suggest parameter. Again, the SDK makes life so much easier. It's going to basically get the client for, that's just a global variable I have just for my search client. It's going to make a new suggest parameter. It's going to determine whether or not I want fuzzy search. So it does support the idea of if I type BART or if I type BAR, I should get BART. If I type BOR, I will not get BART because I'm just doing a regular search and it's trying to match what I'm looking for. Unless I enable fuzzy search, and then it will find that. And then this is just the API call to pass it. And I'm telling it to use the quote author suggester. So when I created the index, I had that suggester section. I told it, look in the quote author field. The name of the suggester is called quote author. And it's going to pass in my parameters. So I have to tell you about that because you're going to see it immediately as I start to do it.
Question?
Yes, sorry.
So you're running the site locally. So you're publishing just the search aspect to Azure?
Yes.
So the keys are similar to define like config or whatever?
I'm sorry?
The keys.
The API key. Yeah, I have it in a config file. Yes.
So for practical purposes, would you recommend like putting this into a separate DLL away from your web app in case you want to swap out search providers at some point or something along those lines? Or how practical would that be if you're tied into the SDK?
I mean, you mean offload, like take out all the entire search functionality into its own DLL?
Yeah.
I mean, you certainly could. I mean, you just pull in the Azure Search Azure Search NuGet packages and put them into your DLL, I guess. I mean, you totally could do that. It seems to me like you're just introducing another layer. But I mean, if you wanted to do that, you certainly could.
Yeah, I was just, the reason I bring it up, I was just concerned about populating like the main web app with a bunch of very specific implementation code where I might want to switch it out later if it wasn't working for us or something like that.
Okay, I see what you're saying. So if you wanted to potentially move away from Azure Search and use something else.
Like we're using Elasticsearch right now, so if we've done this properly, maybe we can best using Azure Search instead.
Okay, so we have, in our product, we have the capability of doing different search providers. We have built-in one that uses basically our search, which is Lucene.net. I've looked into making a search, like a custom search provider, and there's all these particular overrides you have to do, like on rebuild, on whatever. As long as you built that up correctly, then injected whatever platform or feature-specific code you wanted in those properly, I don't see any reason why it wouldn't work. I don't have an example of that, but I guess it certainly could do it, and it would be a way to isolate it.
I was just wondering, like, from your experience, like, if it's worthwhile to do that or not.
I have never done that in a project in 17 years. I've never had the need to do that, but I know it's possible to do it. Then again, I'm sure people do it. I just haven't done it myself. So, but if you really wanted to isolate it down and make sure that all that code is separate, I mean, there's no reason that wouldn't work. As long as you had the Azure Search specific code inside of that DLL, there's no big deal. And there's just some NuGet packages that you bring in for that. Okay. So, did you have another question? Okay. All right. Yes, sir.
You mentioned that the SDK was it sounds like it's basically like a client proxy for the RESTful services.
Yes.
When you were doing all that index building and you were making a whole bunch of calls to the SDK, were those all individual REST calls? Or was that
so I actually only make one call to the SDK. I mean, one call to the actual REST service. In the different areas, I'm only making one call the entire time. So if I go back to create index, all of this code is just setting up this new index, this definition. This new index definition, this is the only call that actually hits the REST service, just that one. And that's basically the same concept. So where I got all the data, I created all that in memory within my application to that list, and I call one call to do a batch upload to pass that list to it. So it's still only one call to the REST service itself. Now I'm using the heck out of the SDK because that's all over the place, but it's not pulling any external resources. And just to give you a frame of reference, this is the same code that creates it using a straight REST API call. I'm not a big I'm not great at JSON, so I'm sure this is horrible. There's probably a much better way to do it, but I needed to do it quickly, and so I did it. So this is basically building up the body of my REST post with all the same information. Actually, this has more information because it has things that the SDK can't handle. But I'm doing the same thing. I get all the way down. There's a lot of it. And I get all the way down to here that basically does a post to the REST API, the same thing. But OK, so if I come over here and if I start typing Bart, you'll notice I'm getting 2 completes right here, Bart and Barney, because it's matching it. So that's the suggester working. As soon as I get to 3 characters, it's automatically making a call. But what you don't see is if I come over here and I do BOR, it's not finding anything. It's making the call to suggester, but it's not matching anything. You have to tell it fuzzy search if you want to match it. And then if I type BOR, then it does some weird stuff that I can't seem to explain yet. It's so small. I should increase that for you guys. I'm sorry. Let me get that in there. That's probably better for you. I'm sorry. I should have done that all along. I type BOR. Somebody's missing that you would think would be there, which is Bart, BAR. It's finding BRO, BOO, and COR. I don't know of any way to manipulate that fuzzy suggestion. I haven't found a way to do it, and I don't know if there is yet. It's something that they're working on. They're trying to see if there's a way to do it. Because right now, basically, Azure Search is going, oh, I think you mean this. There seems to be a way they should be able to manipulate that.
Sometimes they look at the keyboard, like characters.
Which ones are closer together? That's actually, that might not be a bad idea.
When you type BOR, yeah.
So that's why we got the BRO right there.
Yeah, exactly.
Well, that's the best explanation I've heard so far, so all right. So that suggestion happened, and then, thank you, that's a good point. I didn't really think about that. Then the actual search happens right here. Where am I on time? Not half time, right there. So to do the search, I create a search parameter object. I'm trying to determine which search mode. And basically, I'm just going to populate different aspects of this search parameter object. And I've collapsed them here because I'm going to step into each one to show you how they work. But in the end, I'm telling it to search the author field and the text field, and there's my one call. I get the results back. I parse the JSON. I build out some nice links, and I pull out different things about it. But ultimately, what I get down here is my different things. So I get my author, my text, and I'm pulling in the location, which seems weird, but it won't in a minute. And so that's your basic search capability. And you're getting back, for everything, if you want to, you can say, show me the score. So with all your search results, you have, I thought it was in there. OK, so it's in the scoring profile. I'll come back to that because I don't want to show it too much. The first thing I'll show you is how you can do highlighting. Highlighting is actually, it's like the simplest thing, but I think it's one of the coolest. You basically tell it which field you want to highlight the search value in. And Azure Search will go, OK, so it will figure out, OK, you search for Bart. I found it in the author. I found it in the text. What do you want me to do with it? And it will wrap it in whatever you put into here. I chose to use a span with a class, so that way I can manipulate that in CSS if I want to. If you want to make it bold, or if you don't want to show it, or whatever you want to do, you just put in, and it will wrap whatever the value it finds, it wraps it in the results, and it just returns that to you, so you don't have to do anything with it. So all I do is I take the value that they show, that they send me, and I just spit it out onto the page. So here, if I say show highlights, it's actually getting me in the results. It's finding that, and it's wrapping it in here. So if I were to do this, it's really small, but you can see span highlight. Oh, you can't even really see it. I don't know if, can you, I guess you can't even zoom into the inspection window, can you? No. It says, it just wraps it in the span. So that's really cool because it comes back. And because I told it to highlight the text, the author and the text, in this case, it's finding it in the text, and it's wrapping that inside of there. So the highlights are really cool, and it's really easy to do. The next thing I want to show you is facets. So the way the facets work is you have to tell it which field you want to build facets off of. So in this case, I'm telling it build facets off of the author. So when you enable this, the REST service is going to return to you your JSON. There's actually a separate node in there that says these are your facets. So you just have to loop through them. You could totally have more than one field. You could have multiple facets and parse each one individually and display them. But you can only do facets on a field that was marked facetable. So this is where the field definition becomes very important, because if you don't do that, you won't get any results back. So if I say show facets, down here you'll see I have Bart and Homer, and I'm just pulling the count for each one so I know. Now taking that one step further, if I want to filter on just those, if I click that, then now I'm filtered on that particular value. And that filter code looks like this. It's under, what happens is when I click on that link, it does a post back to itself again. And then it will pass the search method a filter object or a filter value, which I then append into my request. So in this case, I'm saying filter the results based on quote author equals whatever value I clicked on, which I passed it the quote author name. So therefore, it filtered it on everything that's just Homer Simpson in the results that it found. So that's how you can work filters. You can only filter on fields that you mark filterable. If you haven't figured out, defining fields properly is really important, because you can spend hours or days working on it and realize that you just didn't mark a field correctly, and that's why it's not working. So, all right, so the next one is really cool. So now we're going to get into scoring. So by default, everything has a score. And Azure Search is figuring out what that score is. If you don't tell it, it's just going to figure out, and it's a calculation of how often does the value that you're looking for show up in however many fields that you said to search in, how many times. And it's basically all these are the same because it's the same value showing up once. So if, let's see, let me do this. Oh, so I'm searching for Bart Simpson. It wasn't the results I expected. Because in doing this, I found by far one of the funniest Simpsons quotes I've ever seen in my life. And I'll just leave you that for a second. When I read that, I just laughed my ass off. All right. So the way it's calculating it, it's trying to figure out what it thinks is the most important scoring thing. But if you notice, I have some in the author and some in the text. You can manipulate those. You can manipulate those results with what's called scoring profile. So when I created the index, 15 minutes. No, I have 30 minutes. Almost 30 minutes. Okay. Yeah, I think I started at 11 because I haven't even shown you the new stuff yet. So let me show you this scoring profile. It's kind of hard to see. It's a little small, but basically what this says is I'm telling you, if this is the quote author scoring profile, it's going to give it's going to weight the author field 5 extra points. It could be 5 billion points. It's really up to you. You define your algorithm. And if I had multiple fields, I could weight them differently and say these are more important. This is easy because I say just weight the author field higher. So if it finds an author, it should come up. The text is the rates on the text field. So when I do a search against this and I specify a scoring profile, if I do quote author, you're going to notice all these come up to the top. So you have, now they're at 2.06. Doesn't really matter what the number is. It's your calculation. But the main thing is these are below it. So these have it all in the author because I said rate those higher. And then these have it all in the text. If I change that scoring profile to say the text is more important, now those are scored higher. And these are scored lower. So through the scoring profiles, you can really start to manipulate that kind of thing and tell it how you want to get your data. Again, I'm doing a very simple scoring profile, one field, but you could have your own calculation. Or you could do something really cool, and let me show you what those scoring profiles look like before I show you the really cool thing, is I'm just doing okay, all the cool stuff is just in the thing I was going to show you. So you can do something based on geolocation. So I am, I wanted to demonstrate showing things that are geographically close to a particular area. So in order to do that, that's the center of the United States. Did you guys just read the article? Did you see about that? The 600 million IPs that are going to like a farmhouse in Kansas? Because that's where MaxMind decided that was the default location if they can't find you. And these people, 600 million, they've had people show up at their house and like threaten to kill them and stuff and leave toilets in their front yard because they like, why don't I have my email? And it's like this old 70-year-old lady living in this house, and that must be her house right there. So sorry, that was a tangent, but it just blew me away. Then I set up some default locations for obviously San Francisco, Seattle, and because I put a quote latitude and longitude in as to where the quote happened, I can now do a scoring profile against them. So I pass in where I want it to be, the default location, but I also pass in the latitude and longitude of, actually it's down here, that's creating the default location I'm searching by. But this is now my filter, so it's going to do geo.distance. I'm sending it the quote location where it happened, plus the geography point that I have selected, because it was easier than having you type in. And then it will try to figure out as long as it's within that radius that I decided. So it knows that those latitude and longitude are geo points. And so it will then do calculations based on how close they are to it. So if I do something like this, and if I don't specify any, here's all my quotes. There they all in the US. Now, if I say all the ones close to Chicago, it's hard to see, but now the center of my map is there. But if I zoom into it, if I say within 1,000 miles, those are all the ones doing that. So all the data is there. It's just doing these searching against it to filter it down to the ones I'm looking for. If I say within 2,500 miles, which is basically the US, so let's see, we'll do 100 miles. Nobody wants to talk in there. Let's see, Denver, maybe I did too low. So it's calculating what all those are and figuring out which ones are close. I guess nothing's happening in Miami. I picked like a bunch of random cities in the US, which is funny that I'm not finding hardly any of them at the moment. But there we go. Now you can see. So that's through just a property of the REST API call. All that processing of which one's closer is all happening in Azure Search, and I'm just getting the results back and throwing it up on the page. So I thought that was a cool thing. All right, so let's see. So I'm not going to go back into this. I'll just show you some more cool things. I showed you the geolocation. I probably, what time is it? I probably have enough time to show you the. OK, I got plenty of time. All right. You can take media files, put them up in Azure Media Services, and you can basically, there's a capability to transcribe text in media services, in Azure Media Services. You can create an index based off of those transcripts so that you can do an Azure search, and it will find out this video at 16 minutes and 22 seconds, and you can have a link to go directly to that. I tried to set that up. It's a little complex. I haven't gotten that one working yet. I mentioned you can have your data hosted in Azure. So in this scenario, and what I did, it's great, except for as this data changes on my local machine, I have to have some way to update it inside of Azure, because Azure needs the fresh data to deal with. Could be like a scheduled task or some kind of timer once a day. It pushes this data up. If your data is already in Azure, like say in an Azure SQL database or Azure no document DB, no SQL database, or I believe it also works in tables, the indexer will actually just run on a thing of up to every 5 minutes, and it will just hit that data automatically and keep rebuilding the index itself. So you don't have to push the data into it. It's constantly doing it itself. They have a ton of samples up on GitHub to do some stuff. So this is an interesting one, and it took me a minute to try to show you this. But you can have what's called custom analyzers. So how does Azure look at the data that you're putting up in it? And you can do things like something specific to a search or a particular index, or you can do match particular words in it. But the one I wanted to show you was a phonetic search. So in order to do this, I have to jump into my older code, because that's where I don't know if the SDK can create this kind of index yet. So the main thing is this code right here. So, and what this is saying is create a new analyzer called my analyzer, and it's custom analyzer, and I don't remember what tokenizer is for, but basically I'm saying make it lowercase, ASCII scaffolding, and the type is phonetic. So what that will do is whatever field I say use this analyzer on, Azure is going to apply that analyzer to it. So in my definition of my, I have to like wipe out my service or wipe out my index and recreate it with the other one. So let me go ahead and do that so it's ready to go. So let me do that. OK, I created it. And this one. Again, the reason I'm doing this in the other one is because the SDK doesn't support it. But if you look over here, these are my different fields. It doesn't really matter which one I'm talking about, but basically in my quote text field right here, I have the analyzer as my analyzer. So basically what I did is I told Azure I'm going to have this new analyzer. I want to be a phonetic analyzation of the things that come into it, and then use it on the quote text field. So now, if I come into my search, it's because I clicked load index in here instead of the index was already created. So there we go. OK, so it took me a while to figure out a word that I could actually use for this too. But I figured out that there, I had to put in a new quote to handle this. So there, OK, why did that not work? Maybe I didn't load it. I thought I just loaded it. OK. All right, stand by. When in doubt, redo everything. OK. Let me delete it. Let me create it. Let me load it. And then let me do highlighting. So because I have the phonetic analyzation on there and there, but you can only get that if you tell it to use the particular type of analyzer that can handle that calculation. And there's different kinds of custom, this one's just the easiest one to represent, but there's different kinds of custom analyzers that you can do. So I thought that was pretty cool. And then you can do another thing is something called tag boosting. I haven't dealt with that yet, but basically in your scoring profiles, I know that you like Nike, and I can boost those specifically just for him because of information I know about him that I passed to the REST service in addition to that. So it'll boost particular tags for particular people. I don't have an example of that because I didn't really know about it until just now, or like about an hour ago when I was trying to come up with more things for that slide. All right, so now I'm at, oh, that's still good. OK, so I'm going to show you the cool thing that Liam Kavanaugh that he gave me. And it's the synonym mapping. So this takes a little bit of setup that I had to do manually. So first, is everybody familiar with Postman? All right, wonderful if you're trying to figure out how Azure Search works. Let's see if I can do this. Let's see, I can't really zoom into that. There's like a, I don't know how to do it on a laptop, but I'll just do this. Is it, well, that's what I said, but it's like a different key. So, oh, there we go. That works. OK, cool, that worked. Except for my mouse is going to move now. All right, so this is a synonym map that I created. And basically, I named it Hank Azaria Synonym Map because I have all these Simpsons characters, and a lot of them are voiced by Hank Azaria. And I don't remember what the format means. But basically, I gave it these different synonyms. So whenever you type one of these things, it will also show you the results for the other one. So you create the synonym map ahead of time. And in this case, I want to get voices that Hank Azaria does. Then in my creation code, this is on, this is on my quote author. Let me just do that. I'll highlight it. So on my quote author field, in my index creation, I'm telling it use this synonym map in Hank Azaria. So what that means is if I type one of those values that it can match up in that synonym map, I should get multiple results. If I can type. Oh. OK, so that one, I'm trying to remember what I used to actually test it. So there we go. Because I typed Mo, it used the synonym map to match up Nick Riviera. Actually, I don't know why. It's matching that based off of comic book. I'm missing the C in that quote. But I haven't played a lot with the synonym map, again, because I just learned about it a week ago. But with that, you can basically tell it these are synonyms for the same value. So you can, if you know the user's searching for one thing, you can actually think that they're talking about something else. Yes?
Can I assume that that fourth result was a typo on your part and not Azure Search failing?
If you see text wrong, it's because I typed it wrong, or I copied it in wrong. If it's not typed correctly, what's wrong in here? Oh, Simpsons D? Oh yeah, that's me. Nah, that's me just typing in wrong. So, okay, so that's the Synonym Map, which I think has a lot of really cool potential and can do some really cool things. So, so moving on. Here's your next chance to win a t-shirt. Can someone tell me why that's funny?
Oh, goodies.
Who said it first? You get the extra large. Oh, actually, I almost made it all the way to you. Very cool. So because Microsoft knew that you actually want to know something about your Azure information, they actually released a PowerBI content pack. So while you're doing all these searches, you can turn on analytics, which basically Microsoft will just keep track of all the search functions that are happening. Things that deal with your index, meaning deal with your service, create an index, load index, delete index, as well as specific index functions, searching against it, re-indexing, those kinds of things. So you have like your most common search things, searches over time, number of searches, when people search for things that don't exist, all that kind of stuff. Now, what's happening in your Azure environment is it is storing this data in its search traffic analytics. It's storing it in Azure. I don't know why that's, oh, it is on, okay. It's storing it in Azure Storage. So if you really want to see what this data looks like, it's really exciting. It takes about 14 levels to get down to it. So you have, I still have more things I could show you, but I may run out of time with that. All right, so this is what it looks like. It doesn't really matter. It's just names, resource, subscription, your GUID, your resource group, name of your service, the name of your search, the search service itself, the name of your search service, the year, the month, the day, the hour, the minute, and there's your data. So, I mean, you can see it's way down in there. So what's really cool is they already did it for you. So you can come over here and you can see your actual search data as it's calculating. I can zoom into that a little bit. Maybe I'll just do that. Let me do that. All right. Oh, that's not doing so hot, is it? You get the picture. So, so this is the dashboard. No, this is the actual report. So this is what's actually happening with your search. So these are when people are searching for things that aren't there, or like the ones that the most popular search, BAR. I get the most results back from that, so that's the one I use the most. Oh no, that's the, yeah. And then this is like searches over time, and so you kind of get all this information, and it'll process it, and it does it like, I don't know, every couple hours it reprocesses those logs, and you can look at the indexing, how many documents are indexed over time, how many indexing requests there were, the service stats itself, how many operations, how many data sources did you work with, indexes, indexers, queries, and then the actual query text that have come in, which version of the API are you using, because there's different versions. The SDK uses one version. When I do the straight REST calls, they're using the preview version, so that's why there's a difference. And then what's really important is your latency. So through here, you can see when you experience latency with your REST service, so you know when you might need to scale up or scale down. So search latency, overall latency, and then indexing latency and things like that. So it's really cool. It's free, and so you can just get it, and all you have to do is just enable the search analytics within your service, and you can start getting this data and looking at understanding what's happening with it. So I'm going to show you one more thing, just because I think I have time to do it. I told you that you could put things in Azure Media Services. You can also put things in Azure Storage. So it has the capability of doing Azure Blob searching, and it supports, there's a page, but it's like PDFs, DOCs, DOCX, Excel, XML, text, and some other ones. And as you put it up there, it basically looks at whatever document that you put in Azure, or the file that you put in Azure Storage. It takes whatever text it is and it shoves it into a field called content, and then it actually searches inside of that to get the results back. From that point, it's treated just like in any other index. The content field is just the value it's going to search against. So in my example, I have, let me jump back over here. Didn't mean to close that. All right, so it doesn't really matter what's in here because you're going to see the results. But inside of here, I have 4 files. And they're 4 blog posts What's that? Oh, sorry, I thought someone asked a question. There are 4 files. They're blog posts that I've written something about. It doesn't really matter what they are. But one deals with jumping into MVC development. One deals with introducing MVPs for a company. One deals with creating notifications for something. And one deals with Azure Search that I wrote like a year ago. You can come into this code, and this is more code that I only have in a REST API version. And I'll show you what creating these indexes look like. 7 minutes. So it's very similar to creating the other index, in which every index that you make when you do against Azure Search has 2 specific fields. It has an ID, has a content. Again, the content will be whatever the content is of the file. They're going to read it, just stuff it into there. I added 2 more fields called name and path. And then this just makes a REST API call to create that index. So the second part of it is creating an indexer, because this is going to come from Azure Storage, which actually I thought was up there. No, it's not. It's down. OK, it's down below there. I have to tell it where to go get the data from and how often to do it. So this is going to create the indexer, which is going to pull my data, my media library, where I told it where it was. And it's going to say pulled every 5 minutes. So it's telling the indexer every 5 minutes, go look into this particular Azure storage account container and path to find anything that's inside of there. And everything, it told you, it gets an ID and a content, but I added path and name. So in my index, I brought in the media storage name, which is Azure's specific name for that document, or that file in Azure Storage, and the specific path to it. And the reason for that is I want to be able to link directly to it. I need the actual path in Azure Storage to it. And then that to do with base 64 to handle characters that come along with it. Then this code will create the indexer and tell it what to do, like where to go get the information and what to do with it. And then the last piece is to, there's 3. Oh, I missed the data source, sorry. That's what I was looking for. This is the first step. You have to tell the data source, then you make an indexer based off of that data source, then you make an indexer based off of that index. And so this is telling it it's an Azure blob type. This is what I was looking for. I just jumped ahead. And this is my connection string to my storage account. And you can't even copy it to steal my storage account if you want to do that. And then, so that just tells it the data source. Then I create the index to say this is where it's going to come from. It's coming from this data source. And then this is how often I want you to populate it. And then after that, the search against it is just like any other search. So I have my score, if I want to show the score, and then I manipulate the values coming back in because I have the path to that. So very long story short, if I search for Azure in there, it will actually read in the document, and it knows that one's easy because it's in the title, integrating Azure Search. But I know in here, in the jumping to MVC development, I mentioned the word Azure. So it actually read into those Azure blob storage files and figured out what the value I searched for is inside of there. So that's another cool thing. I don't think the SDK doesn't support this functionality yet, but you can do it with straight REST calls if you need to. So, all right. So how much does it cost? Well, free's free, so that's good. But you're limited to 50 megabytes, 3 indexes, 10,000 documents. Every row is a document. Now you can use the same index, just do different searches against it. You could totally do that.
Question?
Yes.
So could you use that, so like if you wanted to have like a production and data index for DevOps purposes, would you use it for that?
I'm sorry, have it for a
like
beta?
Like a prod index and a beta index, so that you have to do multiple apps to support data?
Assuming you can live with these limits, yeah, you could use it. Totally fine. I mean, 10,000 isn't a lot if you have a lot of data. I have 100 quotes, so it's easy for me to work with. But if you had 50,000 products, you aren't going to be able to do that because you won't be able to index all of them. And if you needed multiple index for different things. So the idea is you could potentially have the same data, but it's pieced together in different formats. So now you have 2 different indexes. Those are all counted against you. It's whether or not you, but I would certainly do that in a dev environment if you could get away with it. But 50 megabytes, again, it really depends on what kind of data you're storing and how much you can live with. You can move up to basic. It's basically $38 a month. You can scale it up to 3 times. You can have 1 million documents, 5 indexes. And then it gets up to here. And this is really funny because this one didn't exist like a week ago. And they just had this one. and they didn't have this price. On the actual website, it says, give us a call. So that's what I used to have is, give us a call. But now, I mean, these are huge, and you can see $1,000 a month. That sounds crazy for one application. But if you had 30 applications, you could put all your search inside of here, 60 million rows, 200 indexes. Then you get the economy of scale possibly and be able to handle all of them in one time. So, but you can sign up. It's pretty easy to do it with free. I just included this. I'll make sure that Paul has it that it gets on the website, because I have links to all these different things. What is Azure Search, service limits, the REST API. There's a lot of Channel 9 videos, Virtual Academy, if you don't know what Postman is. And then the link to get the Power Search, the Azure Search PowerBI. This one cracked me up too. And with that, this is my information. Feel free to reach out to me. I love talking about Azure. If you had a user group in the area, or maybe not in the area, it's a little bit of a drive. I live in Fort Walton Beach. We're in the other Florida, the Central Time Zone Florida. Most people, you're in Florida, so you know that, but everywhere else in the world is like, there's a Central Time Zone Florida. But I love talking about it, and I love working on it. If you had any questions, again, I mean, if you come across Kentico and you have technical questions, that's my job, so feel free to reach out with me with that. Last, I wanted to let you know about a conference that we are putting on in Las Vegas. If you like Stacy's talk about failure and dealing with bullshit, it's essentially the entire theme. We've reached out to her already. I'm going to try to corner her today. We do have Phil Japitsky. Japitsky. Does anybody know who that is? He used to work for Telerik. He's a Microsoft MVP. He works for another company now, but I've known him a long time, and we have a couple other interesting things. It's a different kind of conference. It's an obligatory thing for my company, so I'll throw it in there. And last, the Cornhole Tournament, which starts in like an hour. There are prizes for the winners as well as the best name. I think we had 3 teams. We need at least 1 more to make it an actual tournament. But please sign up. You can sign up right here in the registration room, or all the way up by the cornhole board. You can sign up there, teams of 2. There are prizes, and I think you hopefully want the prizes, so that will be good. And that's all I have. So anybody have any questions? I think I'm down to like, how close did I get? Oh, 2 minutes.
Yeah,
yes.
I have a couple of questions.
Sure.
So what version of Lucene.net are they running in Azure Search?
I don't know the exact version. I think I took that slide away. I used to have another slide that talked a little bit more about it. I know they support 50 languages, but I don't know the exact version of Lucene.net. I know it's on their website, but I don't even know enough about Lucene.net to know there's a specific version.
And then you talked a little bit about like it automatically updating from a database.
Yes.
That's pretty cool.
So the idea is this, you have a data source where the data is going to come from, and then you have an index that's based off of that, and you have an indexer. So the index is the definition of whatever it is you're going to do. And then the indexer is just telling it how often they re-update to refresh the index. In my example here, I don't really have the benefit of using an indexer because I have the data locally. So I have to push it up there, and then when I create the index, it will create an indexer automatically that runs like every 5 minutes or something, or maybe once a day. But it doesn't matter because the data's on my machine. If I want it updated, I have to push it up there, which causes an index thing. If your data is already in somewhere, somewhere that Azure Search can get to, which currently is only in Azure, you don't have to push the data up there, so the indexer will just hit it. So you can just update your data however you're doing it through your website. It'll just update, and it's however often that indexer runs, it will go hit it to get fresh, to update the index files that you're actually hitting when you call the REST service. Yeah, it's a much better solution. I actually had it working, and then I wanted to reset everything, so I deleted my cloud-based index, and then I went to recreate it, and I couldn't remember how I did it. So I don't have that to demonstrate. Of course, I ran out of time, too, because I wanted to show you the synonym maps. I knew I had to start cutting out something, because like I said, they keep adding more to it, so I just keep expanding. Anybody else have any other questions? Yes?
Just to clarify in my head, the filters, if I had a situation where if somebody was logged in, and that based on their login, I only wanted them to get results from, say, Florida, I could just basically just manually tag that filter onto there and restrict their result sets?
So the filters, as I understand it, you're going to get your results back based on the values that you pass your search call. The filters just filter inside of those results. So that's one way to get it, but you may be getting a lot of data and then filtering it, which is fine. I mean, it's all going to happen on Azure. It's not really happening to you. That's one way you could do it. Another way you could do it is you could use a scoring profile specific to that user that rank those results higher, but then that's just going to give you weighting. It's not going to limit your results. So filtering is probably, yes, your best way to go there. Okay. Yes. Right. Yeah, and it's just another property that you send to that search call to the REST service. And so, and it has, I don't know what the name of that is, but like LE, EQ. There's a name for that syntax. Yeah, whatever that syntax is, you have that capability in your filters, so you can build up any combination of filters that you want. Yeah. So, if anybody else if you have any questions, feel free to grab my card and we can talk later too. I don't want to keep anybody, go eat lunch, but I'll be glad to sit here and keep talking. That's fine. Go ahead. You had another question. Go ahead. I mean, I'm glad to answer them. I'm releasing you if you want to go though.
How often do people catch the board reference that you made like 3 times?
The which one?
The board license plate reference.
Oh. No one has ever caught it actually, no. So I'll give you can have a bottle opener. So, all right, well, thank you guys for coming. I really appreciate the questions. Thank you.